Hey guys, my name's Izza and I'm going to be teaching you about Stoic. It's just going to be a really simple introduction, and I'm going to assume you guys already know what molar mass is and what moles are. So let's just jump right in. So in stoichiometry, there's a lot of things that can be confusing when you're first kind of looking at these really large equations. So before we kind of jump into those, they're not large equations, just long word problems. So before we kind of jump into those, I'm gonna lay out kind of the three really necessary components that'll really help you work through these problems. So the first one is molar mass, and molar mass you use when you're going from grams to moles, or when you're going from moles to grams. And this can be really helpful, in the future, if you look at the units. Oh, excuse me. I should say moles. Right, so this makes sense. You're going from grams to moles or moles to grams because molar mass is in grams per mole, and we'll go into that while we go through those problems. And use the mole to mole ratio when you want to change compounds. And you may have heard this might sound quite familiar, Avogadro's number. You use this when you're converting something from moles to like the number of molecules, the number of particles, the number of atoms, and this number is 6.022 times 10 to the 23rd, and that is equal to 1 mole. Right. So again, these units will really help you kind of figure out and orient yourself in these stoichiometry problems, and I'll kind of show you that as we go through these next two examples. Okay, so this is kind of confusing or can be a little bit overwhelming at first glance, but this is something that some chemistry teachers at MSU might give you, and it's basically what I just said, right? So you're going to start off with something in grams of one compound, and you're going to want to get to grams of another compound. Sometimes maybe you'll start off with the moles of one compound. It really depends on the complexity of the problem. But if you are given grams of, let's say, compound A, and you want to get to grams of compound B, you want to go from grams to moles, right? And that's that molar mass that I was talking to you about. And then you're finally in moles of A, and you want to get to moles of B, and you're changing compounds. That means that you use something called that stoichiometric ratio. That's what this says, or what I called the mole to mole ratio. And then you're finally in moles of B, and you want to get to grams of B, then that's when you use that molar mass, right? You're going from grams to moles, moles to grams. This can be helpful, or it can be overwhelming, but I thought I would include it just as another resource. Okay, so let's actually start off with this problem. It's a little bit more simpler. So let's take a look. How many grams of N2 would be required to produce 2.75 moles of NH3? All right, so let me give you guys the equation first. Now, it's really important when you do these problems that you start off by balancing them. I gave them to you already balanced, but some professors might not. Okay, so now let's take a look at that problem. You want to get to grams of N2, but you are given 2.75 moles of NH3, right? So kind of let's start off by writing that. So we're given 2.75 moles of NH3. And now we want to go from NH3 to N2, which requires that multiple ratio because we're changing compounds. So let's see here. You are given 2.75 moles of NH2. So what you're going from goes on the bottom. So we're going from NH3, and what we're kind of going to goes at the top, right? So let me kind of write that out for you. So we're converting from NH3 to NH2 because that's what the problem is kind of asking us. And you also want to set it up so that your units match, so you can cancel them out. So looking at this problem, you have 1 mole of one mole of N2 and 2 moles of NH3. Again, 2 goes at the bottom because you're going from NH3 to N2. And now we want to convert from moles of N2, so that goes at the bottom, moles of N2, to grams of N2. And when we're going from moles to grams, like I previously said, we use the molar mass. So in 1 mole of NH2, there is, let's just say 28 grams of N2. Okay, now let's take a look at those units. We want to get from those moles of NH3 2 grams of N2, right? So we want to get to here from that moles of NH3. So kind of a way, like I said before, to orient yourself when doing these problems is looking at those units that can really help you if you're kind of feeling a little bit lost. Just know that you have to set up kind of the numbers in a way to kind of cancel all of these out. So moles of NH3 cancel with moles of NH3. Moles of N2 cancels out with those moles of N2 down here, and all you're left with is grams of N2, which is what this problem is asking from you. So go ahead and calculate that. I'll give you a couple of seconds. Okay, and you should have ended up with 38.5 grams of N2. Now let's go into a little bit of a more difficult problem. This one it's not that much difficult. It kind of just starts by giving you a mass and expects you to end up with a mass of another compound. So there's just one more step, and let me give you the equation. The equation is H2O2 Okay, so the problem is, what mass of hydrogen peroxide must decompose to produce 48.64 grams of water? Okay, so here's an equation, and I'm going to give you a couple of seconds just to balance it, just some quick balancing equation practice. Okay, you should have gotten 2 H2O2, 1 O2, and 2 H2O. Okay, so we're given the mass of water, and we're kind of asked what mass of hydrogen peroxide. So we need to calculate the mass of H2O2, and we're given grams of water. So this kind of already tells us we're going from water to H2O2, and that means we need a multimole ratio because we're changing compounds. So let's kind of write out what we have. We have 48.64 grams of H2O. Now we want to use that multimole ratio because we're switching compounds, but we're given grams. So when we're given grams and we want to convert to moles, what do we use? We use the molar mass. Okay, so that first step is to find the molar mass of H2O. I'll give you guys a few seconds to do that. Okay, so that molar mass of H2O is 18.02 grams H2O. It's kind of really important to write out what molecule you're at, like that H2O, H2O2, because it helps you keep track of your work. And so that's that many grams in 1 mole of H2O. Now we're in moles of H2O. So now we can convert or change compounds, right? So this is when we use that mole-to-mole ratio. So we have, so we want to go to hydrogen peroxide and from H2O, right? So from is at the bottom. So from moles of H2O, 2 is at the top, 2 moles of H2O2. And looking at those, that ratio, you see that 2 moles of H2O 2 moles of H2O2 produces 2 moles of H2O. So that's that mole ratio for you. Now we're finally in moles of H2O2, but the problem is asking for mass, which means grams. And when you want to go from moles to grams, what do we use? We use that molar mass ratio. So in 1 mole of H2O2, we have 34.02 grams of H2O2. And now we can kind of look at those units and kind of see how we ended up at grams, right? So we started with grams of H2O2, and you want to get to grams of H2O. Sorry, we started with grams of H2O and wanted to get to grams of H2O2. So looking at these units, we want to have these cross, cancel each other out. So cancel those grams of H2O. Then you kind of see you're in moles, and you want to cancel those moles out. But you kind of also see moles at the top, which is why it's really important to write out what molecule you're working with, because you wanted to get to moles of H2O2, and you want to cancel out those moles of H2O. Then you kind of cancel out those. You can cancel out those moles of H2O2, and you end up in grams of H2O2, which is what unit your answer should be in. So I'll give you a couple seconds to calculate that. Okay, and you should have gotten 91.83 grams of H2O2. Okay, I know that this is kind of a lot of information, but I hope that writing it out, kind of into kind of simpler terms made this topic a little bit more understandable, and it's a lot easier to understand Stoic when you do more and more practice problems. So yeah, I apologize that there wasn't a more simpler way to go through all of this, but I hope that writing it out and doing these problems was beneficial to you guys.